reversed. So there's not anything that will actually carry over here. All right, so 2.1 is all about complex numbers. And this is not what you get when you've been doing math too long. This is basically just, here's what they kind of do. Complex numbers says that everything we did in chapter 1, well, I don't think we really talked about this one. But if you had square root of negative 25, if you try to do that on the calculator, it's going to give you that error message. Or undefined, or no solution, whatever you want to call it. Now here's the key thing on this one. There's no real solution. But what they kind of came up with, they said, all right, well, let's just kind of do this for a minute, because this won't work on a calculator. So we're going to kind of do a workaround on this one to give us an answer that's similar to this one. What they kind of do is they say, all right, what we're going to do is we're going to take this, the negative 25 that we have, and really rewrite that as like negative 1 times 25. And they said, all right, so that we can get an answer from this. Now, it's not going to be a real answer, but what we're going to do is we're going to take this negative 1 here, and we're going to replace the negative 1 with I squared. And that's the whole big, when we talk about complex numbers, that's the one big thing that you have to kind of key on, is that I squared equals negative 1. Or negative 1 equals I squared. If we do that with this one, now we've got the square root of I squared times 25. And we're used to seeing the number first, so we're just going to take that and rearrange it and just put the 25 first. So really it's 25 I squared. Okay, if we do that, now we've actually got an answer we can look at. Square root of 25 would be 5. And if you do the square root of I squared, well, the square root cancels out the squared part. It just leaves you with an I. Now, the I means it's imaginary. It's not a real number. You can't find that on a number line anywhere that you go up to. But it's just an answer that you can kind of get with this one. The one thing I've talked to a few different people, that if you do electrical engineering, you'll do some stuff with I's and I think J's and some other variables they throw at you. They talk about sometimes they talk about vectors with those. But that's the one place where that sometimes you actually will use the I variable, because of with the way the current works and different things. Don't know exactly everything, but I've asked people, and that's the one place I found that where people say, oh yeah, we use the I variable all the time. Well, not all the time, but they use it enough that they kind of hang on to it there. And then what they're going to do is that they're just going to give you some different problems, kind of work through this process and show you some things with it. The very first thing that they talk about with this one, before we do anything else, is standard form for complex numbers. And that's A plus BI. Where A is the real number part, and then the BI, that's the imaginary number part. So really, if you talk about complex form, it's really two parts. It's the real number part, and then it's the imaginary part that you go through in these. Okay, so first thing they're going to have you do is they're going to have you just go back to like what we're doing with some of the functions, and just have you go back through and do add, subtract, multiply, divide. The good thing is when you add or subtract, so they're going to ask you to add or subtract, and then go back and write your answer in standard form. And similar to what we were doing before with functions, with the operations, when you add or subtract on this one, you're just going to combine like terms. The only difference in this one is that instead of using x like we were doing with functions, now you're going to use the I variable. But it's the exact same thing. You're just going to, just combine like terms. Okay, so here we go. Okay, so 7 plus 2i, and then plus 4 minus 5i. And like we were doing with the functions back in chapter 1, the only thing that's different with this one is with addition, you still don't need the parentheses because you're just going to take the parentheses away, that it's still just 7 plus 4. And then you've got the plus 2i minus 5i. That with addition, it's the easiest one. You just put the numbers together. 7 plus 4 is 11. 2 minus 5 is negative 3i. And there's your answer. So you're good to go. Now, the key thing on that is it has to be I squared. If you get I squared, then we can do that. If it's just I by itself is just a regular variable that we're going to treat it that way. Okay. The only one you have to be careful of is the subtraction part, because with subtraction, so use 7. Oh. That just like when we're doing the operations with the functions, that the first part of it is good. It's 8 minus 3i. When you have the minus, you've got to change both of the signs. So it's minus 4, but then it's really minus negative 7. So really that becomes a plus 7. And it's that second one, that's the important one that you've got to change, because again, it's minus the 4, but it's also minus the negative 7. So anytime you've got the negative out front of the parentheses, you've got to change both of these signs. And then once you do that, then you can just combine your like terms. Now you've got the 8 minus 4, and then you've got the negative 3 plus 7. 8 minus 4 is 4. Negative 3 plus 7 is 4i. But again, there's nothing really that you have to do other than just combine like terms with addition and subtraction. Now, when you get to multiplication, that's where you have to make one small change depending on what happens here. And here's the one catch with multiplication. You're still going to multiply full method distributed properly just like you would any other time. The one catch is if you get I squared, you have to replace I squared with negative 1. Okay, any other time you don't do it. Everything else is just straightforward, full method, distributed property, whatever else you're going to do. But if you get I squared when you're going through and working this one out, you have to take the I squared out and replace it with negative 1. So let's say we've got negative 5 plus 3i, and then 4 minus 2i. So for that one, going full method. Okay, so negative 5 times 4 is negative 20. Negative 5 times negative 2 is a positive 10i. 3 times 4 is 12i. 3 times negative 2 is a negative 6. When you do I times I, that is I squared. Okay. Now, and just like with the full method, you always get those middle two terms that you can combine together. So the negative 20 is good. You've got 10 plus 12, so that is 22i. And then the one thing at the end here is when you have the negative 6, when you get the I squared, you have to replace that with negative 1. So really that's negative 6 times negative 1. Really that's a positive 6. So when you do that, now you've got negative 20 plus 6. You can put those two together and make it negative 14, and then drop the 22i back behind it. So any multiplication problem that you go through should, even if it's full method and anything else, eventually it should come back so it's an a plus bi form. You should have a whole number, or a real number, and then you should have an imaginary number. Now, you can always get the option where, it's possible that you could get a negative 12 and a positive 12 where the I term would just go away. And if your answer comes out to be just 14, that's okay, because sometimes the I term may go away. Sometimes it may be that, you may get negative 20 here and a positive 20 here, and this comes out, the answer is just 22i. So it's possible that one of the two terms could go away, but, in the basic setup, you basically should come back to where you've got a real number and an imaginary number, and either one of those two could be 0, so they kind of go away. Okay, so let's give you this one. 5 minus 3i squared. Okay, here's where you've got to kind of fight the temptation. It's not just 5 times 5 and then 3 times 3. That you have to realize that for this one, when it's 5 minus 3i squared, that really it's 5 minus 3i times 5 minus 3i. So you still have to do the full method on this one. The only thing that's different is your two middle terms should be the same thing both times when you do this one. 5 times 5 and 5 times 3. Negative 15, and 3 times 3 is a positive 9, and I times I is I squared. Again, first term's good. You've got negative 15, makes a negative 30. And where you have the I squared term, again, take out the I squared and replace it with negative 1. So that's 9 times negative 1, which will make it a negative 9. So then you have your 25 minus 9, so that'll make that 16, and then minus 30i. Okay, so we've done addition, we've done subtraction, multiplication. Again, it's still the full method. It's still really nothing different. And again, the only difference is it's x, or it's I instead of x. And the one change you have to do is that when you do the full method, when you get the I squared at the end, just take the I squared, replace it with negative 1, so that you get a whole number, or real number, and then the imaginary number to make up the complex numbers. Okay, and then the last of the 4 operations is division. Okay, and division is really, it's one of those times where division really isn't division. That with division problem, you're going to really do one thing here. Now with division, it's really going to be more of a fraction problem. It's not really going to be like the old division of doing the long division setup. This is more of a fraction problem. That really what you're going to do is you're going to multiply by the conjugate of the denominator. And I know somebody's going, all right, well that's great, but what's the conjugate? I mean, I know what the denominator is, but what's the conjugate? The conjugate just means this. You just change the plus or minus sign that is in front of the I term. So for this problem, there's our denominator. The conjugate is going to equal 4 plus 3i. So all we're going to do for that problem is we're going to take this 8 over 4 minus 3i. And we're going to multiply by the conjugate. Now, because it's a fraction, when you multiply, you got to multiply the top and the bottom by that conjugate. Now, the one thing they don't tell you when you do this one, when they set this up, really when they do this problem, because whenever you got this complex number with the 4 minus 3i, you really want to think about that number as being in parentheses. Because that's going to make it more like doing the full method because really that's what we're going to do on this. We're really going to do the full method just like we're doing with the multiplication problem. The difference is now you're doing the full method, but it's in the bottom part of the fraction. Now, here's the good thing about doing this one. The top number can be whatever it is. It sometimes it comes out nice and great. Sometimes it comes out and it's not really anything different than what it was for this one. This one, if you do 8 times 4, that's 32. If you do 8 times 3, that's 24. Okay. No big deal on that one. The bottom part is where the work really comes out on this one. But here's the neat thing about doing this one. Anytime you do the full method with 2 conjugates, there's a shortcut. And this is one you can do it for conjugates if it's imaginary numbers. You can do it for conjugates if it's radicals. You can do it for a shortcut. Anytime it's conjugates, that's because I think there'll be a time later on where it's a chapter down the road we'll talk about conjugates as well. But anytime you do the conjugates, there's always a shortcut if you multiply the two together. That the shortcut is basically this. You're going to do the first term squared. Basically it's f squared minus the l squared. So for this one, we're going to do the first term is 4 times 4, 16. Then we're going to do minus the last term, which is 3i times 3i. Well, that's going to be minus 9i squared. Change the I squared to negative 1, right? So same thing on that one. Take the I squared out, replace it with negative 1. So here's an even better shortcut. Really, it's going to be, if you want to go for a shortcut for conjugates, it's really f squared plus L squared, and you can just get rid of the I part. But that's not really a shortcut. So it's one of those that when you kind of go through it, you just realize that you're just going to do the first term squared, and eventually you're going to come back and make that a plus second term squared. So that's really 16 plus 9. So that'd be 25. Go for it.
You're changing sign with the...
And for this one, we'll put an extra number on the top. Okay, so let's go with 6i over 2 minus I. You want to make this worst case scenario on this one? Or yeah, so we'll go with it. Okay, so let's do 1 plus 6i. Okay, again, get the simple things out of the way first. The conjugate is 2 plus I. So we're going to take the original problem we have. It's 1 plus 6i over 2 minus I, and we're going to multiply by 2 plus I on the top and on the bottom.
But would you have to be the conjugate on the top too?
You've got to multiply the top and the bottom by the conjugate, yes. Now, again, on the bottom, we know what the shortcut's going to be. And that's, if there's any good thing about this problem is, the bottom part, you always get to do the shortcut. And again, because it's the conjugate, it's always going to be the first number squared and then plus the second number squared. So, for hours, if we go through this one, it's 2 squared plus 1 squared. That if it's for the complex numbers, we're going through this one, the minus and the negative one's always going to cancel out, so really this is just 4 plus 1, so the bottom number is always going to be 5. Now, the top is, if you get through the shortcut on the conjugate for the bottom, the top is the one that has, for this problem, this is really where the work's going to be, because on the top part, you don't have a shortcut. You just have to do the full method. There's no shortcut around that one. And I'm going to drop this down to the bottom because there's no way I'm going to squeeze that in here. So doing the full method, we've got 1 times 2 for 2. 1 times that. Again, I would say, just to be on the safe side, go ahead and put 1i. Just, not to miss anything. 6i times 2 would be 12i. And then 6i times 1i would be 6i squared. And that's over 5. All right, again, the 2 is good. 1i plus, and this is where sometimes it's good to put the 1i, because sometimes if you're not, people will just tell me the answer is 12i. 1i plus 12i would be 13i. And again, with the I squared, we have to take I squared out and replace it with negative 1. So if we do 6 times negative 1, that part is really negative 6. And 2 minus 6 would make that negative 4 plus 13i. And that's over 5.
So is it like the formula for the number of the I? That's like 13 times 4.
Yeah, they always want the real number first and then the I number second. And sometimes this one, sometimes they'll want you to break it up in 2 parts. I'm okay with either answer. Sometimes they'll get picky and tell you it's this answer, but sometimes they'll ask you to break it up in parts. So we'll say this is an or answer because you could write it this way or this way. They'll have you write it this way sometimes because if these fractions will simplify, if this had been 4 over 8, you could have simplified and made that a half. But if they don't simplify, it's really no need to break it. So if you look at the numbers here, and if you see anything that could simplify if you broke it up, they want you to break it up. If you're not able to simplify it, you don't really have to break it up. Yeah. Well, and this kind of puts it in, I was going to say a little bit different form, but really it's just a different way of looking at it. So, okay, last thing we'll do. And we'll come back in after the test, because again, we'll do tests next time, and then we'll pick back up with a little bit of 2.1, but mostly 2.2. The last thing we'll show you that's here that we'll just make sure that we know what it is the quadratic formula. And with the quadratic formula, this is when you're given the equation ax squared plus bx plus c equals 0. That if we were doing the factoring and different things we were doing back in chapter 1, if you get a problem that doesn't factor and you're trying to find solutions, the quadratic formula will give you an answer. Maybe it's a lot more work there, but at least you always get the answer. And here's the formula, if you've forgotten what it was. Now, I'm going to add a little bit extra to it, just because sometimes this helps out. We're going to do the negative of b plus or minus the square root of b squared minus 4ac over 2a. And the extra little bit I'm going to do is that both of these b values that we're plugging in, I'm going to put those in parentheses. Because usually if there's any mistake people make when they're working through this one, and usually it's not even this one, it's this answer, this one little part right here, sometimes people mess up. So if you put those in parentheses, that should take care of most any mistake you might make as you're working through this thing. A little more than what the book will show you, what most formulas will do, but if you put those 2 parentheses in there, that usually takes care of pretty much any question. All over 2a. Yep. Okay, let me give you one problem here. Let's see. Yeah, we'll do this one. Okay, and just to save us a little bit of time, because we're almost to the last minute here, they'll say use the quadratic formula to find the solutions on this thing.
It's just when you can't figure out factors.
Yeah, because that's the first thing I would do. If you can factor, if you look at something, you go, hey, I can factor that. Go ahead and work with. Like if this had been 7, you could have factored find the factors of 10 that would equal 7. You could have used 5 and 2, and you'd had it real quick. There's no factors of 10 that'll get you 6. So this one you have to go back and use the quadratic formula. So for this one, your A value would be 1. Your B value is -6. And then your C value is 10. And as we get farther along into chapter 2, we'll do more about the A, B, and C values, but for now, that's all we're going to do. And so for these, they're just going to ask you just go back and plug it back in. Now, here's why we do this. Because a lot of people, if you don't put that B value in parentheses, they won't, the minus negative, they'll forget about the double negative part, and they'll just put one negative, and then the whole answer is off because of just one simple little sign. So I'd say go ahead and put this in parentheses here. Same thing when you do the B squared on the inside. Put that number in the parentheses. The A is 1. The C is 10. That's all divided by 2 times 1. Okay. Minus negative, make that a 6. -6 squared is going to be 36. And that number, every single time, whenever you do this B squared part, that B squared will always be positive. Because you're going to square it. If it's negative, you do a negative times negative, it makes it a positive. If it's positive, it's going to be positive anyway. It's this number that sometimes is negative, sometimes is positive. So if we do -4 times 1 times 10, that's a -40. Divided by 2. Okay, so we've got 6 plus or minus the square root of -4 divided by 2. Now, here's where they bring in the whole I number part of it again. That if it was just square root of 4, yeah, square root of 4 is 2, right? But if you go back to the very first thing we talked about, if you have the -4, the only thing it does is change that answer from just 2 to 2i. Because, again, you're really doing -1 times 4. You can take it out and make the whole imaginary thing. So really this part, when we do this one, is going to be plus or minus 2i. So we have 6 plus or minus 2i divided by 2. Now, here's the kind of the preview here. If you broke this thing up, couldn't you do 6 divided by 2, right? 6 divided by 2, and we're going to break this up basically in 2 parts. Because 6 divided by 2 is 3. 2 divided by 2 is just 1, so that's 3 plus or minus 1i, or just 3 plus or minus i. Now, I think with the online homework, I think they actually have a plus or minus button in there now that you can do this. If not, one answer would be 3 plus I, the other answer would be 3 minus I. But I'm thinking in the last year or two that they've gone back and added in that plus or minus button, I think. Because I know used to it wasn't there, but I think that button is in there now to kind of go back and do that.